React hooks have been the standard way to manage state and side effects in React for years now, but if you're coming from class components or just getting started with modern React, the sheer number of available hooks can feel overwhelming. I want to give you some good news. Hooks are actually much more intuitive than they first appear, and you probably only need to master a handful of them to build professional React applications. Today we're going to walk through every React hook, from the essential ones you'll use daily to the specialized hooks for advanced use cases. Plus, I'll show you exactly when and how to use each one with real code examples. Let's start with the hook you'll use most often, useState. So what exactly is useState? Well, it's React's way of letting functional components have their own internal state. Here's the basic syntax. We're using array destructuring to get two things back from useState. The first element, count, is our current state value. The second element, setCount, is a function that updates that state. The 0 we pass to useState is our initial value. Here's how it works in a complete component. The magic happens right here on the onClick line. When we call setCount with a new value, React re-renders our component with the updated state. But there's a crucial detail about useState that catches many developers off guard. State updates are asynchronous, and React batches them for performance. Take a look at this code. You might expect this to increment count by 3, but it only increments by 1. The reason we use the functional update pattern is to solve this. Now each update gets the most recent value, and count increases by 3 as expected. And it gets even better with useEffect, which handles side effects. Here's what's happening in this example. The first argument is our effect function, the code we want to run. The second argument is the dependency array, which tells React when to rerun this effect. In this case, the effect only runs when count changes. Let me show you exactly how this works with a more complex example. The key thing to understand here is the dependency array. We include user ID because we want to fetch new user data whenever the user ID prop changes. But what if you want to clean up after your effect? Here's how it works. The return function is our cleanup code, which runs when the component unmounts or before the effect runs again. The cleanup function is used to remove side effects, like event listeners, timers, or subscriptions, when a component re-renders or unmounts, preventing memory leaks and unwanted behavior. Now let's dive into useContext, which solves the prop drilling problem. So what exactly is prop drilling? Well, it's when you pass props down through multiple component levels just to get data to a deeply nested component. Here's the old way. But with useContext, look at how clean this becomes. See how this one change eliminates the need for prop passing through parent? The child component directly accesses the context value, making our code much cleaner. But there's even more with useReducer, which is like useState's more powerful cousin. When you have complex state logic or multiple related state variables, useReducer shines. The implementation is surprisingly elegant. Instead of multiple useState calls and complex state update logic, we centralize everything in a reducer function. This pattern scales beautifully for complex state machines. Now let's talk about performance optimization hooks. useMemo prevents expensive calculations from running on every render. What this is doing is memoizing the filtered result. The expensive filtering operation only runs when items or filter changes, not on every render. In a real application with thousands of items, this optimization can make a huge difference. useCallback is similar but for functions. Without useCallback, handleAddItem would be recreated on every render, causing child component to re-render unnecessarily. It ensures the same function reference is reused between renders. This is mainly helpful when passing callbacks to memoize child components. Here's where things get interesting with useRef. Unlike state, ref changes don't trigger re-renders, making them perfect for accessing DOM elements or storing mutable values. Breaking this down line by line, we create a ref with useRef, attach it to our input element, then use it in useEffect to focus the input when the component mounts. The current property gives us direct access to the DOM element. But refs aren't just for DOM access. They're also great for storing values that persist across renders without causing re-renders. Here, intervalRef.current acts like a box that holds the interval ID across renders. Unlike useState, updating a ref's .current value doesn't cause the component to re-render. This makes refs ideal for keeping track of values like timers, WebSocket instances, or previous state without affecting the UI rendering cycle. Now watch what happens when we explore some advanced hooks. useImperativeHandle works with forward ref to customize what gets exposed when parent components use refs. Inside useImperativeHandle, we expose a controlled set of methods, focus and clear, instead of leaking the entire underlying DOM element. This means the parent can only interact with the component in the ways we explicitly allow. By wrapping the input in forward ref, we make refs work with custom components which normally don't forward refs by default. useLayoutEffect is like useEffect, but runs synchronously after all DOM mutations. This is crucial when you need to read DOM properties and make changes before the browser paints. In this example, we measure the element's height immediately after the DOM is updated, but before the screen is painted. This ensures the displayed height is accurate on first paint, avoiding a flash of incorrect content. While useLayoutEffect is powerful for DOM measurements and sync layout changes, it should be used sparingly since it blocks the paint until it finishes. useDebugValue is a development-only hook that helps with debugging custom hooks in React DevTools. When you inspect this hook in React DevTools, you'll see the debug value alongside the hook, making debugging much easier. A more advanced use case would be building custom hooks that combine multiple built-in hooks. Here's a practical example of a data fetching hook. By combining useState and useEffect, we centralize fetching, error handling, and loading state into a single reusable hook. Any component can call useAPI open parenthesis URL close parenthesis and instantly get back clean, ready to use data without repeating boilerplate code. This makes the UI simpler, promotes consistency, and follows the DRY, don't repeat yourself principle. So we covered all the essential React hooks from useState for basic state management to advanced hooks like useImperativeHandle and useLayoutEffect. The main things to remember: useState and useEffect will handle 80% of your needs. useContext eliminates prop drilling, useMemo and useCallback optimize performance, and useRef gives you escape hatches for DOM access and persistent values. Custom hooks let you extract and reuse stateful logic across components. I hope this comprehensive walkthrough was helpful. If you enjoyed this content, feel free to hit that like button and subscribe for more. Thank you so much for watching. Have a great week.